Hello, so in this video I'm going to talk about this problem 2461 maximum sum of distinct subarrays with length k. So it's a LeetCode medium problem, and the problem statement says we are given with the integer array nums and integer k, and we need to find the maximum subarray sum of all the subarrays that meet these conditions. So the condition is it should be of length k and all the elements needs to be distinct, and out of all these subarrays we need to return the maximum subarray sum that meet these conditions, otherwise return 0. So let's take a look at sample test case. So we are given this array and desired length is 3, and so these are the subarrays 154 542, and out of these subarrays this one contains the maximum sum, so we have returned this. The other subarrays contains multiple occurrences of the same element, like 9 in these cases, so that won't meet this condition. So we're returning 15 because this contains the maximum sum out of all the valid subarrays. So let's take a look at the constraint. So we are given the maximum of 10 to the power 5 of array length and k, and element value can have up to of 10 to the power 5. Okay, so the proof of solution is to, for every I index we're going to iterate till I plus k index. So that basically n square solution if k equals to n. So that won't be accepted here because 10 to the power 5 is a big number, so that will be 10 to the power 10, and at max we can perform 10 to the power 8 operation in 1 second. So the optimal solution is to use a sliding window. So basically we're going to keep a k length window, and we're going to slide this throughout the array, and in window we're going to keep all the unique elements. So for example, if we met any element which we have already in window, so we're going to shrink it till we have all the unique elements. Also we are going to slide the window as soon as we met the condition of k length and all the unique elements. So we're going to capture it some, and we're going to slide the window on the right side, and we need to shrink it from the left side. So yeah, that's a traditional sliding window approach. So let's just implement it here. So let's just define a macro so that we don't need to write it again and again, long and long. Yep. And array. So basically we need couple of variables. For example, I, which represent the left pointer, j represents also right pointer. Initially it will be in 0, and n represents array size, and we also need a running sum, right? So skip it, just name it as running sum, and max sum, right? Because we need to return the answer, right? And we also need to store all the unique elements, so we can use either map or set. So we're going to use the set visited. Yes, so let's just start. So until our right end met the last index, we're going to run this loop. So now we're going to insert the element in the window, right? First point is in the window. So before inserting, we need to check like whether this element already exists in the window. So we can do this using visited find array of j. So if this condition met, which means the current element on which we are at is already exists in our window. So what we need to do is like we need to shrink it, right? So for shrinking, what we need to do is like we need to erase it from the left end. Also we need to remove it from our running sum array of I, and we also need to increment the left pointer. We can do it here. So after this step, we are sure that current element array of j is not in our window anymore, so we are safe to add it in our window. So we can now add it window like this, and we need to add it in our visited window again. Yes, and now we need to check visited dot size. escape if we have hit any valid window. So what we need to do here is we need to capture the sum, right? So answer is equal to maximum of running sum. And now since we met the window, now we need to slide the window again. So for that we need to shrink it from the left side again, and we need to remove its sum as well, and we need to increment the left pointer. And now since we are good we are good to go, so now we can just increment the right pointer as well. Now we can return the sum, so it looks good. So we're inserting here, and we are also shrinking the window, and once we find any valid window, we are also shrinking. Looks correct. So let's just run it. Yeah, it's working perfectly fine. Let's just submit. Yeah, boom. Yeah, thanks for watching this video.